Hello everyone, good afternoon. Thank you so much for taking the time and making it to the dialogue today. My name is Shruti Kantha. I am the Senior Com Specialist at Epic India, and this is our sixth edition of the Dialogue series. It's a flagship series where we call a close group of experts and discuss topics that are at the intersection of energy, environment, and climate. Today, joining us in today's conversation, who wins, who loses, how rapid cooling could narrow global inequality. We are joined by our own postdoctoral scholar Anshuman Tiwari. Before joining EPIC India, Anshuman was a postdoctoral fellow at the Environmental Markets Lab at the University of California. He holds a PhD in environmental economics from the London School of Economics, a master's degree in public policy from the University of California, Berkeley, and an undergraduate degree in computer science and engineering from the Indian Institute of Technology. His research examines how environmental and climate policies affect equity and livelihoods, something which he is going to talk in detail in today's presentation. Moderating the conversation and joining us today is Professor Shrikant Gupta. He is a distinguished expert with over 30 years of experience in policy and environmental economics. He is currently a visiting senior fellow at the Center for Social and Economic Progress. He currently focuses on carbon trading, climate finance, and climate mitigation and adaptation. He is also the Executive Education Senior Fellow at Lee Kuan Yew School of Public Policy, National University of Singapore, adjunct faculty at IIT Delhi, and former professor of Delhi School of Economics. In the next 1 hour, we'll hear Anshuman talk about how a change in how we react to climate also has an impact on the economic inequalities globally. He'll present his research findings for the first 15 to 20 to 25 minutes, and which will be followed by a conversation with Mr. Shrikant Gupta, and then we'll open the floor for questions. So I'll invite Anshuman to please come.
Yeah, thank you to Shrutikanta, Ashrabad, and Kaushik. I think he's traveling for inviting. I'm glad to present this paper here. I think it's very topical. The COP is going on as well right now. Let me motivate this by essentially pointing to the fact that we know poor people in poorer countries, especially, are the ones who bear the burden of climate change the most. So even with the same sort of extreme heat weather, two people, let's say construction workers, one in LA, one somewhere in India, the person on the right in LA is privately better adapted and socially better adapted. What do I mean? This person can afford better clothing, and they also have access to social insurance. Both of those things are missing for that person. I think this is a snapshot, in a way, of this inequality that exists across various sectors. You think about the fact that, across agriculture, across health, across labor, electricity use, climate change is expected to hit poorer countries and poor people in poor countries the most. That's one level, the impact side. The other side is the temperature rate rises themselves. So that graph on top there, it essentially maps where temperatures will increase the most as a result of climate change. So what you see there is, carbon emissions are all the same. You can emit them anywhere. But atmospheric meteorological processes are such that places which are hot today will get hotter in the future. There's another way in which you exacerbate these climate impacts. So one, you have these impacts hitting poor people who can't adapt, and two, of course, they are also getting hit much more. And I'm talking here about temperature. You can, of course, think about other sources of climate impacts, maybe extreme rainfall, flooding, droughts, all sorts of other things, right? Like you have typhoons, hurricanes, as we call them, all of those things. So, another thing I suppose all of us here are aware of, we should be asking, is who has contributed the most to global CO2 emissions? And I think in this regard, climate change is a stock problem. It's not a flow problem. So it doesn't matter how much, matters to some extent how much you emit this year, but what really matters is how much did your country, or if you're thinking of yourself as a person, how much did you over your lifetime emit? So what you see here is a graph you can find online anywhere, but essentially it's the developed world today, the rich countries in the world, the OECD countries, which have emitted perhaps 70-80% of overall CO2 emissions that are in the atmosphere. And so ultimately these are the guys who are mostly responsible for this problem, because that is a stock problem. The other, of course, aspect of this is all of these emissions have allowed them to become rich. So you have, because you have increased your GDP per capita, as you see here, this is a graph of GDP per capita on the x-axis, and how much emissions overall over time have are attributable to each country. You see again that countries which have emitted the most, the US right there, upper right quadrant, very high per capita income, very high emissions overall. And so, these guys have become rich as a result of all these emissions, especially in the past, and that has allowed them to build some sort of resilience as well. That's part of the story. So climate resilience requires a bunch of investments, both private and social, again. And if you're not rich enough, if you are essentially hand to mouth in many ways, it's hard for you to build that resilience. So there's another way in which I think of inequality as being important. And so here's a map of projected future mortality rates under business as usual carbon emissions. So you get certain climate change as a result. This accounts for the fact that countries will grow in the future. So countries like India, but also countries in sub-Saharan Africa, which are poor today, will grow into the future. So this is at the end of the century, in 2100. How many, this is mortality rates here. So what's the increase in mortality rate in 2100 compared to 2001 to 2010 averages as a result of business as usual emissions? And what you see here is, most of these mortality impacts are focused, they're essentially concentrated in today's global south, the poor and hot countries of today. Even though they will become not necessarily rich, but they will get richer. They can't adapt fully. Another interesting aspect here that you might notice is that countries in the global north, at least on this one metric of mortality rates, are potentially gaining. So what you see here is today's hot places are becoming hotter, really bad places to live. But those places which are cold today might actually become slightly livable, at least on this temperature metric. Another thing that will keep, coming up over and over. In the electricity space, it does come over. So, for example, think about how much cooling you require in December, say in Norway. So, if you don't have that many cold days, the amount of electricity you need, the number of hours you need to run your heater goes down. And so essentially your power requirement, comes down. Your grid doesn't have to bear the same load. So that's another way in which you gain. So a country that became rich through emissions is, again gaining in this other way. That's kind of also showing up. So another dimension.
That's RCP 8.5?
Yeah, so this is RCP 8.5.
Which many people don't pass.
Of course. So you can also do it under RCP 4.5. The relative rankings will not change, because that's the essential point here, that you will still see perhaps smaller impacts in the south, smaller impacts in the north, but the fact that there are winners and losers will not change. Okay, so what, this whole understanding of inequity in climate impacts should make us think about, what should we do? And I think there is some momentum in terms of the fact that there have been recent climate impacts especially across the world, that motivates, action. You see it every year at the COP again. People call for action, etc. And there is this, of course, famous Paris Accords, which essentially say there is a certain target at the end of the century for a global surface temperature we want to reach. Maybe it's 1.5 C. But there's no understanding of, how do you, the speed at which you get there, what does that buy you? So let's say you do it very rapidly. Can you reduce all of this inequity that I talked about on all these dimensions? Can you reduce that inequity if you were able to reduce carbon emissions quickly, or carbon equivalent emissions? Because methane is another gas that matters in this particular case. So that's what we are going to study in this paper. Study the equity consequences for climate impacts, in this particular case mortality rates, of reaching some target, a target that policymakers end up setting. But let's do it either slowly or rapidly. How does that change these inequity in climate impacts? And so I'm going to focus on a personally evocative outcome. For a good reason, I will not focus on dollars. I will not focus on monetizing benefits. It's just going to be about mortality rates, so the lives lost. And the other thing we're going to do here is we are going to account for very granular, very local scale differences in vulnerability. What do I mean by that? So usually, this is what climate models do. The scale that you see here of the units, that's where climate models operate. So you have one impact, say for the US, one for South America, one for South Asia. This is the level at which we will operate. So we have about 25,000 regions of the world. So for each region of the world, for every year, from today to 2100, we can disentangle differences in mortality impacts as a result of global emissions. So that's the level of granularity we can get at here. Okay, so just to be specific, we'll study 6 scenarios. Okay? All these 6 scenarios, again remember, they will end up in the same at the same point in 2100 in terms of EMST.
In the previous one, you didn't mention that. Right?
Oh yeah, the age group. Well, the age group, it's a bit technical in the weeds. But yeah, you can also have differential impacts for older people and younger people. Yeah, so we also have some of that. But we are going to study these 6 scenarios, like I said, which will all end up in the same GMST target, the temperature overall across the world, average temperature, which is what we care about when we talk about climate change. Right? And so this is avoided emissions in terms of gigatons of carbon dioxide equivalent from 2 different gases. So we'll do 3 scenarios for carbon dioxide, 3 scenarios for methane, and 3 different temporal profiles. So one is going to be a rapid scenario, but I'm going to call it fast here, fast or rapid. So we start.
Is that emission or mitigation?
This is mitigation. So this is avoided emissions.
Yes.
This is
That way.
yes. This is avoided emissions. Thank you. Yeah, that makes sense. So this is avoided emissions from business as usual. So that's what I'm plotting here. There are of course level differences because methane has a much higher warming potential than carbon dioxide. So that's why you see differences in how much methane versus CO2, but it ends up in the same GMST. How does that happen? Essentially this. This is avoided warming again. So how much degrees Celsius of warming you can avoid corresponding to those same 6 scenarios that I was talking about over time. Right? And what you see ultimately is this is where the black line is business as usual. If you did nothing, that's kind of what RCP 8.5 says. In Rahul's point, you can also do this with RCP 4.5, RCP 6. But you get some baseline, and then if you avoid emissions relative to that black line, you get different warming scenarios. So this is global warming, average temperature across the world. So you see, there's a very different temporal profile. What you see is methane gets you cooling very fast, whereas CO2 takes some time, but they all end up essentially at the same point in 2100. How does this change inequity? That's the question we want to ask. Okay. All right. So I think people are aware of all this terminology, but I want to put it up here just in case. But let me move on. So there's a bit of math here. Sorry about that, but I'll try my best to explain some of this. Okay. And I wanted to be clear about what I'm doing. So the data in this paper come from a published paper by Tana Carlton et al. That's one of the co-authors on this paper. Essentially what they do is they have mortality as a function of some, nonlinear temperature. And that's essentially how the literature captures effects of temperature and related effects. Okay? And that effect of temperature is mediated by 2 things. One is your average temperature. So if you're a hot country, let's say like India, you might have hotter temperatures on average, way higher than let's say places in the US, in the East Coast. But just because you have higher temperatures doesn't mean you see higher mortality. Right? Because people are adapted to that. So that's one mechanism which is here. That's where the T mean comes in. If you have a hotter average temperature, you are more adapted to it. So your mortality should come down. The second here is the GDP per capita mechanism. So that's adaptation through income. So if you're richer, you can invest in hospitals, you can invest in all sorts of social resilience infrastructure, all sorts of things, right? So GDP per capita is a way to capture that. So we have both of those operating to essentially change the damage that you get for a given temperature. And so that's what that paper does. Now, after you estimate all that, the interesting thing for us is that this is all from historical data, right? That's done by historical data. Now we can use this machinery to project into the future what is likely to happen for a variety of future scenarios. That's what was done in the paper, and that's the data we have access to. Okay, so rather than talk you through words, let me just show you on a map. So there's two different sources of uncertainty here. This is future warming relative to again 2001 to 2010 levels, average temperature across the world on the x-axis. So there are all sorts of, there's much variation here, right? That all comes from global climate models. So you have 33 climate models which predict very different things. They have very different assumptions, and so that essentially is all this uncertainty we want to account for. Some climate model might predict very hot, some might predict cold. So that's on the x-axis. Just focus on the orange, right? Orange is the end of the century. So that's how much variation exists. Climate models disagree. In 2100, some climate models say, well, the future is 9 degrees hotter. Some say, well, no, actually it's 3 degrees hotter. We want to account for all that. So we have that on the x-axis. On the y-axis, we have other uncertainty. So that comes from econometric, uncertainty essentially. That's on the y-axis. This is just for one region of the world in upper income. So the green is 2050, middle of century. The orange is 2100. So we have this kind of cloud of points for 25,000 regions of the world for every year, going from today to 2100. That's what we leverage to estimate damage functions. So this is Ghana. You see an increase in temperature, you get more deaths per capita. Right? This is Oslo. If you increase temperature, you get reduction. Again, this goes back to the earlier point. Most deaths in cold places happen because of cold. So if you increase temperatures, then they'll benefit to some extent. So we have that captured here. In two regions of the world, we'll do it, for all regions. So how we do it is essentially I'm showing you that here. We have again all of that uncertainty I talked about. And so what we are after is those alphas and betas. It's a quadratic damage function we are after for each region, for each year. And so here's like some examples of that. So let's spend maybe 1 minute on this. Again, the x-axis is that same change in the global mean surface temperature. For the same change, same global warming, you can get very different effects across the world. So say in Multan in Pakistan in 2050, you get very high damages as a result. A lot more people per capita would die if you get, say, 5 degrees of warming. At that same level of warming in Oslo, you might get benefits. And there are places all, in between. So we leverage this. So we have all those 6 scenarios I talked about, where we can see what the change in this x-axis is for each of those scenarios. That's what I showed you earlier. We can plug that in for each of these damage functions and calculate how many lives will be saved or lost as a result of all of those actions. That's the plan. That's what we are going to do now. Okay. Ashu, let me know how much time I have. And, sometimes I get...
I think it would be good to wrap up in like 5-10 minutes.
Let me just show you the results.
Can you spend one more minute on the previous slide of why Bhutan would be, the most affected in
Yeah, no, that's a great question. Yes.
compared to India particularly?
Yeah, so that comes down to a couple of factors, right? So one is, yes, of course, Bhutan, I think is hot, but Agra is also hot. Baghdad is hot, right?
Yeah.
But which places are likely to get richer is the other question.
I see. That's a very interesting.
And so this of course, there's uncertainty in terms of which projections you use. We use SSP3 here. Maybe other predictions will differ on that. But that's a good question.
Is population demographics
Yes.
also modeled age-related
Yes.
mortality risk?
Yeah, so that goes back to Shrikant's point. We have age disaggregated mortality rates for the historical data. We use those to do the projections into the
But
future.
you have a projection of the population
Yes.
spread
Yes,
for 2100.
that's true. From now until 21.
Yeah.
Again, those come from standard modeling, EASA and others. So any of the issues that come with that, we will also inherit those.
Just to add to Kavita's point, so these are deaths per million.
That's per million.
Actually, if you look at actual deaths, it will be much worse because Agra's population is probably.
That's a great point as well. So I'll show you both mortality rates and lives saved separately. Because ultimately we care about lives saved, right? Like it's not the rate, but the rate is easier to, of course, understand and it's easier to model. That's why we do that. Okay. So I'm going to show you results. So I just want to flag that this was all work in collaboration with EDF at the beginning, Environmental Defense Fund. They funded this project, and Climate Impact Lab is where all of this work sits in Chicago. They are a sister organization of ours. You should read their work. I think Ashwin was here as well earlier, so that's great. Okay, so I'm going to show you a bunch of equity metrics. I showed you the 6 scenarios. I showed you what you do. Now I'm going to show you what happens when you do all of those 6 scenarios to lives saved or lost in different ways. That's the okay. So let's start with this. So this is annual global lives saved or lost, again, because it's possible mitigation benefits the south but hurts the north for each of those decades. Okay. What you see here, I've also added for comparison, some well-known drivers of mortality, right? So what you see here is that essentially a lot of lives saved from doing rapid action. Essentially, if you use methane to mitigate and you do it rapidly, you get the most bang for the buck. That's our main point across the world. You still do get a lot of lives saved, even if you did the worst thing on a particular one of our scenarios, which is the delayed CO2. Still get a lot of benefits. But you could do a bunch of other things and get a lot more lives saved, to the order of 10 to 20 million. These are annual averages. If you add them up over the century, that's a lot of lives. So pursuing very quick action using methane is probably a good strategy if you care about equity. That last thing doesn't come out necessarily from here. So let me show you a map.
When you say methane,
Yes.
do you mean using it less or tightening the upstream emission leakage or?
Yeah, so I think the particular mechanics of how you get those avoided emissions is not something we speak about. It's essentially a machinery where you can feed in any of those. So if there are ways to plug methane leakage from oil and gas installations in the US for a cheap price, that's great. And we should get the same outcomes that we care about. If you want to do that from paddy in India, which is perhaps more expensive for Indian farmers, we get the same answers, but we are silent
That's
on
the
the
problem.
cost.
Because
Absolutely.
affordability
Absolutely.
political
Yeah.
will /
Yeah,
bunch of stuff.
maybe we can talk about that more in the discussion. What we are pointing out here is that there are benefits. The costs of doing that are a big part of equity as well. Absolutely. So again, this is just another way to show it. You see that a lot of lives are now, that whole thing gets flipped, right? If you essentially mitigate, you save lives in this global south, and you lose in the north. There's mortality rate actually. So to the point about population, where do people live? You can use that as an overlay. And now you see, places which are more densely populated in the south, global south, they are the ones that benefit. There's actually not that many people who live in the north. So, perhaps migration will happen. That's something we don't account for. It's possible people will move to the tundra, and then you get some losses. But, that's somewhat uncertain.
So, Rinchuman, I lost this. So, why are lives lost when you're mitigating?
Yeah, so this goes back to the fact that, today climate change is benefiting colder places. So, places like Norway, for example, which, where lives are lost not necessarily due to heat, but more due to cold. So, if you have fewer cold days, that's going to reduce how many lives are lost. Like I said earlier, it shows up in other sectors, electricity demand and other sorts of things. But life saved
But
from
wouldn't the differential baseline, so if I'm a person in the global south,
Yeah.
and I say let's clean up or do these scenarios, and now even after adjusting for the relative improvement, I'm still better off being in the north.
Yeah, no, that's a fair point. If you're talking about the levels, yeah. Life in general is better off in the north in many ways.
I meant just from a mortality risk,
Mortality
absolute
perspective.
risk,
Absolutely.
climate.
Yeah, this is
not delta. mortality.
This is change in relative risk and how that translates into life saved. But perhaps this is the policy instrument we get. At the moment we are here, we are thinking about how do we avoid emissions. And so if we care about inequity, and this is what perhaps we should care about. Okay, so I'll just show you one more couple of more ways of doing this. Like if you look at the bottom 20% of 2020 incomes, those regions, most of the lives are being saved there. This is total lives saved, across the whole century. Most lives are not being saved in the richer parts of the world. And another way of showing it is this Lorenz curve, which I think is a cool figure, but I think it will take too long to explain this, so I'm not going to get into it. I'll leave you with this one last graph, which again takes those regions from 2020, or regions of the world, and divides it up into the bottom 20% by income in 2020, the poorest, and then the richest on the right side. And what I'm showing you is the share of lives saved. So most again lives are being saved. 28% of lives are saved at the end of this century, which is 2100, in the poorest 20 regions, 20% of the world. So any way you cut it, essentially climate mitigation today will save lives disproportionately in today's poor places, even if they get richer later, accounting for all that change in how rich they get. Therefore, delaying mitigation of methane will save fewer lives. That's the policy relevant thing that I'm talking about. How we do that, I said, whether the cost implications are important, I think that's a great question for discussion and for debate. I'll leave it at that.
Okay, well, firstly, I'd like to thank EPIC for inviting me to moderate this. And as a footnote, I was the first speaker in the dialogue series. So it's wonderful to be back. Thank you. So, well, firstly, of course, I think we are all agreed that this was a masterful presentation. Just so much work that you have in this paper and that you were able to distill it in such a concise and very useful way, I think is very useful, is very good. And also just to sort of, your from what I've understood, this is obviously a massive exercise. And from some inside information I have, how many terabytes of data do you have on this? 60?
About 14 terabytes.
14 terabytes of data has gone into this to do this. So in a way, it's like phase 1, phase 2. So you have the original work that you had in the Carlton 2022 paper. And I think what's really interesting for us sitting in the Global South is that you have now extended it into the equity dimensions. Yeah. Which is not what they had. So what they essentially had was just the response functions.
Yes.
And then now that you have done that. So I have one nerdy question, which I don't think you need to answer, but then I will ask you some more. We'll talk about some more practical things. So obviously, the whole idea is that when you look at it from a theoretical perspective, for example, when Nicholas Stern talked about early action, so that was nested in this whole idea of this is very nerdy, the intertemporal elasticity of substitution, right? So it's basically you're saying that the future and the present cannot be substituted. So the parameters, what I'm talking about, the eta parameters or the pure rate of time preference. So. So what I would like to sort of, again, these are just sort of, this is not a theory paper, but in a sense, do you think that what you're doing in terms of saying early mitigation is saying that the pure rate of time preference is close to zero, and secondly, the curvature of that, of the function says that you cannot substitute tomorrow for today. I'm sorry, that's not if it's an unfair question.
No, thank you for asking. I don't know if you can hear me on the mic. Let me see. Yeah, I think you can hear me now. I think this question tells you that Srikanth is a hardcore economist. So, the reason we focus on life saved is sort of to sidestep some of these issues. Because I think there is a bunch of modeling uncertainty, not necessarily uncertainty, it's a stance you have to take. And then, a lot of these researchers are not necessarily based in the Global South. Nick Stern at least takes the stance that discount rate should be low. That's great. But I don't know if I would essentially say anything more than just the fact that we try to sidestep some of these issues. I think a problem here, I mean, maybe one thing I'll say technical on this is valuing lives is difficult. So you are trading off an extra, say, life year against some consumption. Like if you're abating, that's some potential consumption you could have put into use for people who are living. And how do you do that is not so obvious. Like it's perhaps another technical wrinkle, right? So of course there are ways to value life saved. You have the dailies, and you have VSL, other ways of doing it. But I don't think necessarily Nick Stern talks about it as well. So.
No, so I think that in a way, what I was saying is that the theory rightly done actually bolsters your point about
That's great.
equity, because if you do believe on these, because that that the future, the present should matter as much, the whole thing about the rate of time preference, then it really is. So it's really backs this up in a way, or what you do is backing that up, or either way.
Implicitly, yes, we have a zero pure rate of time.
Yeah, exactly.
Yeah.
And I think it's really important, this work that you are doing, which in a way, because this Carlton 2022 paper is basically saying, well, it's not just her, it's a whole 20 of the top economists and so on, is basically saying, of course, there'll be damages and so on and so forth, but your work is putting the searchlight on equity. So anyway, sorry for that nerdy kind of a digression, but I think like we are all seeing that, you have this scenario, slow methane, fast methane, and so on. And I think we saw that in all those scenarios, actually the one that does best is fast methane. I think that's there. So what do you think is, so two-part question, what do you think is really driving that result? Because again, I'm not so much up with the data, but it seems that the methane emissions per se, in terms of the CO2 equivalent, are not, their weight is, but so anyway, you would know.
That's a great question, yeah.
And the second thing is, just from there, is that, again, maybe I can ask the second part later, so you can answer, and you can.
So methane, I guess, like I alluded to it earlier, it has a higher warming potential than carbon dioxide, and it affects the global weather patterns much more rapidly as well. So the main intuition here is, if you avoid methane emissions today, what you end up getting is a very quick reduction in global temperatures straight away. And so that's the main reason you start getting those benefits quickly. Now, that might be the case. There's a countervailing force here. If you remember those graphs, the damage functions, they're curving upwards in temperature, right? So temperature increases in, let's say, in the next 20, 30 years are not going to be as extreme. The most extreme temperature increases will come later in the century. So you might think, well, actually, this quick reduction in methane shouldn't actually buy me that much then. I'm only at 2 or 3 degrees Celsius. I'll get to 8 potentially. I mean, that's crazy, but now climate scientists think maybe it's 4 or 5 at the max. So let's say you get to that later on in the century. So why is it that you're getting more benefits from doing it today? The answer to that is these reductions are sustained. So it's not as if we are saying you do geoengineering one time, you get all of that methane out of the atmosphere and then you pump it back in. We are saying you will have to do sustained things. So you'll have to reduce, say, emissions, again going back to the oil and gas example. Leakage has to be capped, plugged, and that has to be sustained over time. Then you do get these benefits. So I guess that's the other intuition that is important here.
But that's the part 2 of the question, was that now if we think about policies and the sort of sources, then as we were discussing earlier, in the global south, there's obviously a lot of methane that comes from livestock, from paddy cultivation, and so on and so forth. And then, so, what is your sense of, so when you say fast methane, and, because I'm focusing on methane because that seems to be one of the things, as you've already explained, that's driving your, the headline results, So what's your sense of where the reductions could be, should be? I guess given your whole emphasis on equity, there's a giveaway there in terms of...
So the paper by the EDF climate scientists that we worked with. So we used their scenarios for methane, and so they talk a little bit more about where those reductions might come from. It's very interesting that they don't really talk that much about the paddy from Indian rice cultivation, let's say, for example. I mean, a bunch of their interventions are, like I said, oil and gas. I mean, you could be thinking about many other sources, which are mostly in the, again, rich parts of the world. And, again, you alluded to this, but if you care about equity, as an economist, I would care about the marginal benefit and marginal cost. So yes, we can, this tells us the benefit of doing something, but what's the marginal cost of achieving those reductions done correctly? So what does that mean? Well, you should think about, for every ton of methane I avoid from whichever source it is, what's the welfare loss? Not necessarily the income loss, the welfare loss. So if a ton of methane avoided from Indian paddy imposes a lot of, maybe in monetary terms, it's not massive, but Indian farmers are poor. So even a smaller monetary loss might actually hit them much more. So that's a bigger utility loss. From the economics perspective, again, slightly larger monetary value of reducing 1 ton from an oil and gas installation in the US might not lead to that large a utility loss. So I mean, again, that's using.
That's a very interesting way to put it, Anshuman. Actually, I hadn't thought of it, because typically what you've said, I was thinking the opposite. So when you say, well, we know, for example, I don't know what's the exact number, how much, but I would say about 50 to 60% of methane emissions are from ruminants and agriculture and so on. Of course, all the ruminants are not
in the US.
They are in New Zealand,
Yeah.
New Zealand and so on.
The US, yes.
But nonetheless, there's a significant amount that comes from agriculture in the global south and from cattle, because we do have the world's largest cattle population. We don't need to be told that. We can just step out and see. The idea is that, so when I was thinking about marginal abatement cost, I was immediately thinking dollar, and I think the dollar cost per ton is lower. But you have put it in a kind of a very mind-bending way that it's really the dollar cost is in terms of welfare. So I don't know exactly what metric to use, but intuitively your point is that.
Yeah. No, I understand the marginal abatement cost point, but I think again.
But marginal abatement just in terms of like here it's $10, there it's 20, but that $10 cost if borne by the farmers here are in terms of whatever.
Yeah. So I mean, another way to do it is like equivalent variation, right? Like, so yes, if you care about the lowest marginal abatement cost, please do it in India, but then make sure they are compensated.
Yes.
Now you can think about this in terms of deforestation in the Amazon.
Yes.
We are asking all those guys to bear the burden of deforestation.
Yes.
What is the mechanism to compensate them for the losses? And it's not, I think it's important to compensate them for the utility loss, not the monetary value.
Yes. So I think is this your third? Then the next paper you're going to a sequel to this, because I think that's a very interesting point, because once you are trying to tell us here are the equity implications and we buy that, then I think the next question then is where these reductions, if fast methane and fast CO2 we haven't talked about, if that's happening, where, how, and then obviously the simplistic economics is okay, lowest marginal abatement cost, but then you're talking about EV, CV, those sorts of ideas and distributions. So I think that obviously is the next kind of stage of this work, because I think your work really begs the question then, that okay, these are the equity implications and this is what we need to do. Then if we were to really, so suppose we accept this, that fast methane is the best way to deal with equity, then I think the next logical question is what we are talking about, how, and then your sense is that it should happen in the global north, fair enough, and you have given the reasons for it, right, that the cost per ton may be higher, but it's just that whatever the equity weights or whatever is higher. So I think that's really the
Or I mean, again, I think I'm making an economic argument for equity here. I mean, again, I think the whole point of COP and the IPCC and all of these global climate negotiations is to think of all of us as one community. I mean, if that is the case, then I would just use standard economic tools, utility maximization, right? Not necessarily monetary value. and then essentially argue that yes, I mean, if you want mitigation to happen in the south, and some of it is happening anyway, like our energy systems are changing rapidly because it's in our interest to do all of that. It's cheaper for us. But if you want us to do more expensive, costly things, maybe there should be a mechanism that allows compensation in a fair and efficient manner that actually happens. Otherwise, perhaps we will end up in the situation we're in. It's hard to.
Yeah. But anyway, I think just to end on a slightly, well, I think we should open it to the floor because there are people here who I'm sure have a lot of things to say on this. Is that, of course, the reality as we're sitting in this room and what's being playing out in South America, thousands of miles away, is somewhat less cheering, if I may just put it that way. So, but anyway, I think these are very interesting. This is a very, very fascinating piece of work, a logical extension of the earlier work. And focusing on equity, I think, is absolutely something that I think is very central. I may add that there are other dimensions in this work is progressing on agriculture, for example. The same group has been working on the impacts and adaptation on agriculture.
And other sectors also.
And if I may be correct, could I summarize that yes, you will have economic growth, which will help adaptation, but you can't grow out of this problem. Economic growth doesn't take you away from this problem, and that even if you, that also the impacts are still, the impacts of delayed action are worse for the poorer parts of the world, and by corollary, bigger if you do it quickly. Would those be fair summaries, or would you want to?
Yeah, I think that those are fair summaries. I would probably qualify just by saying that economic growth, of course, also increases your pie. So I think that affects your utility ultimately. So perhaps if you're very rich as India in 2100, if you lose GDP, this is not about lives. If you lose GDP of 5% as a very rich country back then or in the future, perhaps it's not as bad as losing 5% today. So a slight wrinkle in that.
Okay. Well, I think it would be good to invite comments from the audience.
Hi, everyone. I'm Kushagra from Center for Science and Environment. Very interesting paper. I felt like the messaging at the end, the last slide where you're talking about the income bracket, that could have been more pronounced, because if you look at the lives lost thing, that would just be like, based on UN projections, would still be like 0.06% of the world population back then, like lives lost. And the rich would be like, that's not a big problem for us, and that would still be like just 10% of the average lives that are lost. But when we look at on that scale, and in poor households, when we see like if the person is the breadwinner, then a life lost in that income bracket is more pronounced. So it could be like lives lost and then lives affected.
Right.
I think that would make the messaging of inequality far more pronounced, especially for it would make the paper more like advocacy specific.
No, that's a great point. Yeah. I think the best we are trying to do with our data limitations is at the region level, lives lost or saved. But you're absolutely right. I mean, even within a large region, Delhi would be a region in our paper. Within Delhi, you will have, of course, a whole distribution of people and who gets, benefits and who gets losses. So that's fair. I mean, maybe that's also for the future work. Maybe we can just say that this is the case, but I don't think we can argue that much based on the data we have.
And if I may add, because we are sitting in EPIC, the AQLI, this very famous AQLI says that the average years lost in the Delhi region is 8.2, right?
Yeah.
But I was trying to understand this. I was writing something that this 8.2 is on average, which does not mean people like me who have access to air purifiers. So if you actually look at it by income categories, the burden is disproportionate on people who don't have defensive behavior. So that kind of bolsters the fact. So even for an AQLI, that 8.2 is probably, I don't know, just arbitrarily maybe 3 for me and much more. So that sort of distribution is also quite interesting. Rahul, do you have any? Is it mic? Do you need a mic? Yeah, I think it is.
So, I really like it. I mean, obviously, the biggest thing, not biggest, but one of the big things is you're looking at lives. Life is a life is a life.
Yes.
Now, on that front, there are some people who believe that there could be global warming is good for me. There's literally I can grow food in the north that I couldn't before. But tipping points, if I look at all my sort of, Europe could be devastated, even it's not about the temperature, but non-linearities that are very hard to model. So maybe you could also look at scenarios, because if I look at negotiation, there's a cynical view that the Montreal Protocol worked as quickly as it did because the light-skinned people were hit by it.
Yeah.
And so that dynamic, how would it change if you sort of found?
No, I think that's a fascinating point. I mean, there are 2 points there. One is on the non-linearity side, like the potential tipping points. It's really hard to model. I mean, I completely agree that we don't have it. Like, so if there are catastrophic risks to the entire world,
but asymmetric, like Europe,
asymmetric as
specifically
well.
from AMOC is one of the well-known.
Yeah, I mean, I was looking at like watching some video a couple of days ago. The AMOC especially seems to have a lot of connections with various things, including the Indian monsoon. So if the AMOC weakens, the Indian monsoon might also weaken. It's all very interesting and fascinating. I'm sure scientifically, at the frontier, people are working on it. But the second point I think is also great. So if it is the case that light-skinned people were hurt by the Montreal Protocol and that's why action was swifter, this would point in the other direction, of course. And so, partly this is almost like trying to shame, some parts of the world into perhaps doing more. Maybe that's one way to look at it. The other is, I mean, perhaps like you can also look at it as a game, like it's a game of chicken. So if countries like India or large countries in sub-Saharan Africa on their own could do certain things to abate, like let's say changing their energy systems, while also making sure other countries don't free ride in the global north or elsewhere. There are a lot of advantages of that, including all those spillover benefits for other countries from that sort of approach. It's another potential way of looking at it. So an extension of this could just be what happens for India if India decides to reduce its emissions by a certain amount. You have to model it, but that would have to assume that other countries don't free ride or ceteris paribus, etc.
If the chair permits, just a short question on methane, since it's not your focus, but it's a pathway. The example you gave where you tighten the leakage is a no-brainer. It doesn't have implications that spill over. But if you now said stop using methane as a fuel and then do something else, for some countries that may mean more coal, hypothetically, or it could mean more cost. So there is that trade-off.
Yeah.
So then, if we look at methane use as a fuel, not so fossil fuel methane as opposed to nature-based methane, that's overwhelmingly in the global north. The per capita consumption of natural gas, India vis-a-vis Germany is something like 30, 40x, versus the US is 60, 70 or 80x, etc. And so now you're back to that same dynamic of, okay, why should I do it? Let me look for a market mechanism let's just do it somewhere else. How would you tackle that?
Yeah. No, those are great questions. I mean, I think it's hard to figure out what kind of market design would work here, essentially because you're thinking of some sort of compensation here. I mean, if you have an international market in these things that actually works, that'd be great. We know that's very difficult. I don't know if I have an answer for you. I think it's an interesting question to think more about.
No, I think it's a very good question. I think that really right now you have a kind of a thinking box that here if you do this, then there will be there'll be better in terms of fast methane, and in a way that bolsters the whole equity story that the South has been pushing on, not just as a philosophical way or a, I mean, that's obviously there, but the idea is that yes, this is also you're showing us numbers.
Yes.
So I think that's really useful. Rahul's question is also valid. That ceteris paribus. So the idea is, but it is not that. So I think that's, to be fair, a third paper, so to speak. I mean, it's an important question, and I think it's a sequel, in a way, to what you have done. And
It's a bunch of papers.
it's a bunch of papers. It's a whole research agenda, and I think it's a very useful and important research agenda. And particularly if countries of the world, particularly in the global South, think that yes, fast methane is really the way out, then the question is how. And hopefully, it's not that if you're doing this, then you're having fast methane along with slow CO2 or even the
Right.
negative, that sort of stuff
Yeah.
is, I think, really important. But if there are any other questions, yes. So we have to. So yes, sir. Please identify yourself here.
Myself, Mukesh Budania from Eravat Research Foundation, IIT Kanpur. So I have want to understand actually that you mentioned life loss or life gain, that kind. So if you can consider some confounding factors or some moderators, can you predict what will be the air quality like in north or in the south, considering same temperature? Like, okay, this will be the temperature in this year, this year. And so what will be the air quality point of view? And then again, now people predicting, okay, this is the air quality, mortality rate is this. And based on that factor, only temperature and considering your data only, just put this factor, air quality perspective, what will be the mortality rates?
No, that's a great question. I mean, I assume you work with Professor Tripathi.
Yeah.
He works on air pollution. So
Yeah.
I think, that particular question, the air quality question, we tried to wrestle with that a little bit because, of course, these are co-pollutants. So, but the heterogeneity in air pollution emissions and carbon emissions is massive. What do you mean by that? So, you can tighten pollution standards a lot because those are local pollutants. And so if most of the benefits are doing all of that is very local, there's a lot of internalization, to use economics lingo. If the US acts, if states in the US act on air pollution, it benefits them. And so that's what you've seen over 50 years. Once they've decided to do that, they've cleaned their air, but that does not apply to carbon emissions. And that's the standard problem of global externalities. The co-pollutant story is more valid for the global south. I think it actually strengthens the reason for us to do stuff on our own, especially for those kinds of sources where you have both carbon and air pollution, and there's no trade-off between them, right? So, I would have to think carefully about what exactly. So, coal, I think, might be a good example of that. If you burn coal, you are, of course, creating air pollution emission, and you're, using coal, that's carbon. If you avoid coal, you're doing 2 in 1. I think it's very source specific, kind of question.
Uh,
Thank you.
Hi, Suresh from Epic India. So I had a question. I would like some more clarification, especially on the adaptation function that you mentioned. So it's a function of both historic temperature and some GDP. So if I understand correctly, take that and then project it into the future. But what's the underlying assumption that these adaptation parameters will continue going on? So, for example, now we get Multan has, lower deaths than Europe because of heat, because of your looser clothing. That's your historic temperature. Over a gradual sustained increase in heat over 50, 60 years, we could very well see adaptation rates change, and that would significantly alter the results. So, what's the pathway? How do you project those?
Yeah, that's the how of it technically for every mechanism is an extremely difficult thing to do. Like if you're just thinking about loose clothing, I could think of air conditioning, all sorts of things.
I just meant, sorry.
Yeah, no, I understand your point. I'm just trying to say that the way of doing it is we are trying to be flexible to allow for as many possible adaptation pathways as you can imagine, but we can't cover all of them. So if at a certain income level, some regions care more about health, then that's possible. You make investments in, say, improving the way your roads function, so people don't get heat strokes on the road. That's possible, right? So like same regions or regions with same income, one of them might do that. We'll miss some of that, of course. On average, I guess the point is, if you do get richer, you are able to do more. So that's the trade-off we have to make if you want to tell a global story.
So I wasn't talking about specific pathways. If you get richer, you're able to do more, and you do, beta something more.
Yeah.
But how do we expect that beta to be consistent over good 50, 60 years, regardless of the pathway that you take?
So that has not been consistent in the past as well. Right? So the 50 years of data that we have, things would have changed over time. But again, it's a mediator here is income. But I think the story you're telling is more about technology, specific things. So there's a great paper by Michael, if you haven't looked at this, Michael Greenstone, on mortality in the US South that changed over the 20th century. So a lot of people died, in the first half of the 20th century in the US because of extreme heat.
I think this has been a very great presentation and conversation, and has given us a lot of food for thought. So thank you very much.
I just want to thank you again to Srikanth, and I think you have had a great idea today for a paper. So I think you should also work on you're a theorist as well. So.
Yes. I think we should. Yeah. Okay. Thank you.